We are from Group C10 presenting Experiment 8, Gravimetric Determination of Calcium. 1. Preparation of the unknown solution. Weigh about 1.3 grams of the dry unknown sample and transfer it into a 250 ml beaker. Measure and add 30 ml of deionized water using 50 ml graduated cylinder and 12 ml of 3 mol hydrochloric acid using 25 ml graduated cylinder into the beaker. Stir the solution gently using a glass rod until the solid has completely dissolved. Next, transfer the unknown solution into a 100 ml volumetric flask. Next step is preparing for the precipitation. Measure and transfer 25 ml of the unknown solution into each of the three 250 ml beakers. Dilute with 75 ml of 0.1 mol hydrochloric acid using 100 ml graduated cylinder and add 5 drops of methyl red indicator solution to each beaker. The solution should appear slightly pink. At this stage, all 3 beakers contain the same mixture of the unknown solution, acid, and indicator, ready for the precipitation process. After that, measure and add 25 ml of ammonium oxalate solution and 15 grams of solid urea to each beaker. Stir the solution with glass rod. This will cause calcium oxalate to form as a white precipitate. Before trying the precipitate, don't forget to weigh 3 clean, dry watch glasses using an analytical balance and record their masses.
3 beakers was left to boil gently on hot plate and covered with watch glasses until the indicator turns yellow. We filtered each hot solution through weight funnel and suction used. All precipitates have been transferred to filter paper and washed with cold water 3 times. All 3 precipitates were dried in oven for 24 hours and each carries different weights.
Next, for our data analysis, we need to calculate all 3 wave percent values, mean standard deviation and also the relative standard deviation. First, this is our experiment result and we need to calculate the mass of the precipitate. So the mass of the product minus the mass of the watch glass and then minus the mass of the filter paper for each of them, and then finally we will get the mass of the precipitate. Second, we need to find out the gravimetric factor, which the molar mass of the calcium is divided with the molar mass of calcium oxalate monohydrate, and we will get 0.2745. Third, the calibrator pipette volume 25 ml is divided with the calibrator flask volume 100 ml and we will get 0.2500. Fourth, find the mass of the solid in a liquid. As we use 1.3 gram during the experiments, hence 1.3 gram is multiplied with 0.2500, we will get 0.3250 gram. Fifth, calculate the wave percent for all 3 trials. For example, for the first trial, to calculate the mass of the calcium, we take 0.47 gram, multiply with the gravimetric factor and we will get 0.1290 gram. Then to calculate the percentage of calcium, we take 0.129 gram divided with the 0.325 gram and multiply with 100% and we will get 39.69%, and so on for the trial 2 and 3 with the same method as above. To calculate the mean, we use the wave percent which had obtained and divided by 3 and we will get 41.10%. To calculate the standard deviation, first use the mean that we had obtained, then subtract the mean from each data point to find the deviation. Square each division and sum the square deviation. Finally, divide this sum by 1 less than the number of data points. Last, we will get 3.99. For relative standard deviation, 3.99 is divided with 41.10 and multiply with 1000 and we will get 97.80. By using the Microsoft Excel, we will get the same answer as we manually calculate. Hence, we found out that the relative standard deviation is very high as we calculate. This suggests that there were random error in this experiment, such as leaving some impurities and losing some precipitate during filtration.